In this video, I want to describe the values that are output from the describe method. So I have a very small data set here that I have already loaded. The data set has just one feature, one column. I'm going to show you right now in Excel. It has a real price feature with 20 records. This is loaded here already. I'm going to run this. And here's what we have. We have count, mean, standard deviation, minimal value, 25th percentile, 5th percentile, and 75th percentile. And then we have the max as well. So I want to break down each one of those values here. So first of all, how about we format this data in a slightly better readable way? Right now, it's in a scientific notation. So we're going to be using a bit of formatting. It will make things a little bit better to visualize than just calling describe. So I'm going to call describe. I'm going to comment this line out. And I'm going to apply some formatting here. This whole thing, I'm not going to break it down. What am I doing here? I'm just applying formatting to those numbers. So let me run this again. And now we have more readable numbers. For instance, we have counts. Count is the number of entries, the number of records. So if we have a look, we have count 20, and we can see in our Excel that we do have 20 records here. You see the count? 20? That's fine. So that's what count is. Mean is the average. We have big numbers here. Those properties, they are in the $1 million type of range. So it's a little bit hard to visualize without formatting it with thousands or currency. So let's change this a little bit here. In our Excel, let's format this column as dollar value. So I'm going to expand this a little bit here. So now we have something that we can read a little bit better in currency formats. So for us to be able to format this a little bit better, to better visualize this, I'm going to change once again the way we format this output. So I'm going to comment this out. I'm going to have another line here. Actually, a much simpler line, to be honest. If we run this, now we can see with thousands, with comma breakdown the thousands. So it's better to visualize and we have a better understanding of our data here. Next one here, we have mean. Mean, let's go back to our Excel. What is the mean? The mean is the sum of all prices divided by the number of prices, the number of entries here. So what we're going to do is we're going to sum this up. We're going to just put this down here and you're going to say mean equals to, I'm going to use some Excel formulas here. I'm going to say this is equals to the sum of this cell, which is cell A2, down all the way to cell A21. So when we sum this all, this is the total amount, the total value of all prices of the houses together. Now, I have to divide this. Divide this by which number? By the number of entries. We have here 20 entries. So let's divide this by 20. And now we have $1,111. If we look at this value, this is the mean, and it should match this value here. So that's what the mean is the average. Now, standard deviation is slightly more complicated than the other ones. So let's break this down. First, I'm going to show you the formula. So here is a standard deviation formula. Don't get too scared about how it looks like. It's just the sum of each value minus the mean to the power of 2 divided by the number of records, and then we get the square root of that number. What this means, what standard deviation indicates, is how it spreads the data is from the mean of that data set, how far apart they are. When we get to the final number of our standard deviation, it means that most values from that data set, from that feature, are this far apart from the mean of the data. So I like to use Excel to break it down and help us understanding the different pieces of this formula. So let's go here to Excel and let's start by creating a new column here. We're going to be calculating the difference between the real value and the mean. So I'm going to say equals to, for the first entry, A2, so we have A2, which is this cell here, minus the mean, which is D2. This is the first part. We have the difference there. Let's go back to the formula. Now we have to put this to the power of 2. So I'm going to say this, the difference to the power, we use this symbol in Excel to make it to the power of 2. That's the value. We have a huge value here. And then we have to sum them up. So we have to do this for each entry and sum everything. And then divide by the number of entries. So let's keep going here. So we did this for the first entry. How about we do this for the second entry as well? I can just copy the value of the formula right like this, but there's a little problem there. It keeps increasing the line number. You see A3, A4, A5, but it also increases the D as well, and we don't want that. So for us to keep this cell fixed, we can use the $sign right here. And we can try this again. We can just copy it over, go to the very end, and now we have the difference between the real price and the mean to the power of 2. At the very end, what we have to do, we have to sum this. As you can see by the formula, we have to sum everything. So let's do that. To sum, I can go to the very bottom here. I can say equals to sum. Sum of what? Sum of this cell all the way down to the last one. We close this. By the way, you can do the same thing if you are using just Google Sheets. It works just the same way. So this is the sum. Now, we have to divide that sum by the number of entries. So we have 20 entries there. Here's a new number. And last, we have to get the square root of that number. Well, Excel has a formula to calculate the square root. So we can say SQRT of this. And here is the standard deviation, which should be a match with the value that was provided by our describe. Let's have a look. As you can see, we don't have a perfect match here. We have $400,000 here as standard deviation, but in our Excel we have 390. So what's going on here? Well, what's going on is this. There are two ways to calculate standard deviation. One is if you have the entire population, the entire data sets of the records that you want to calculate the standard deviation for, you can use the precise total number of entries. However, if we just have a sample of the data, we have to use a slightly different formula here. We have to subtract from the total number of entries, we have to subtract 1 from that. To be honest, don't ask me why exactly is 1. How does that work out? I know that you do have to subtract by 1 if you don't have the entire population, if you just have a sample. So when you do that, as you can see, we now have a match. Look at this, $401,064. So we have an exact match. So this is what standard deviation is and what it means. As I said before, it means the spread of our data. If the mean is around $1,100,000, most of our data is within the distance of 400,000 plus or minus mean. So majority of data is right there. And when I say majority of data, if our data follows a normal distribution curve, then roughly 68% of our data will be located within $400,000 away from the mean. Again, a lot of math here, I get it, but I just wanted to unpack a little bit more what standard deviation really is and what it means. The next ones are a little bit easier to understand, and we're just gonna order our data based on the price. So I'm gonna go back here I'm gonna get rid of this part here. I don't want it for now. Now, what I'm gonna do is I'm going to select all our data and I'm going to order this data. Order by what? By value. The lowest one will go on top. The highest one will go at the bottom. So on Excel, I can go to sort smallest to largest. As you can see, we have minimum here, 300,000. Look at there. We have minimum 300,000. We have maximum 1,800,000. And here is the maximum one. So we got those two sorted out. The other ones are the amounts that represent, for instance, 21st percentile. It means that 25% of the data is lower than $880,000. So as we have ordered this, if you go down here to the list, we have 20 entries. So 25% is right around the five first entries here. So this is the 25 percentile. The amount that you have there is 880,000, which is just around here. It means that 25% of the data is lower than this amount. And we have the other ones as well. 5th percentile, it's this number here. This number is located just around the middle of our data, which we have the next 5. Remember, we have 20 entries here, so I'm gonna just put a different color here, and we have that amount just around here. So 5% of the data is lower than this number. And then we have the last 3rd percentile, which is the 75th percentile. Will be located just around here. Let's change this color, and we have it just around here. 75% of the data is lower than this number. But you may say, Ederson, this value is not matching any one of the values there. Yeah, there is a way to calculate those numbers exactly. I'm not going to walk you through that, but the point is that this is only required when you have an even number of entries. In this case, we have 20 entries. If we had 21 entries, we could spot exactly the value that would be representing the 25th percentile, the 50th percentile, and the 75th percentile as well. But in this case, because we have an even number of records, there is a minor calculation that needs to happen, which goes beyond the explanation so far. But hopefully this gives you a better understanding of how to interpret these numbers that are provided by the describe methods. That's it for now. Thank you very much.